Usual, you saw that on Monday. Who's played this one? Super Mario Maker. A lot of you. Okay, I don't know. I feel like most engines you can kind of get for free today. But Nintendo said, you know what? Can we package up some of our development tools? And they managed to sell it, not necessarily as just a game engine or creation tool, but as a game itself. There are a few interesting things about this Mario Maker game/engine hybrid. One of those is the release timing. Okay, what did this game come out for? Yes, the Nintendo Wii U. Does anyone own that? Okay, not that many of you. Who owns a Switch? Raise your hand. That's a little bit better, okay? Nintendo Wii U, one of the least successful consoles in Nintendo's history. Its main gimmick was that it had this touch screen. It looks kind of like a Fisher-Price toy over here. You can see it. And you could play on the touch screen and do things and manipulate things while you had it going on the screen, big screen in front of you, okay? Now, Nintendo really struggled to make this matter, okay? Often you had a lot of traditional games that would beam like a map or an inventory screen to the bottom tablet, and that was kind of it, okay? A lot of bigger attempts to use the tablet were kind of seen as gimmicky, a little bit burdensome. It's kind of a heavy tablet, so doing anything with it was annoying. But you know what's really great about having an additional tablet in addition to your screen? Just flat out, you get more screen real estate. If you need a second monitor, who uses a second monitor sometimes? Okay, you know that can be very nice. If you happen to have a game that has a lot of information that needs to be dealt with, then that could be a really good fit for the Wii U. And for my money, Mario Maker might have been the killer app that the Wii U was really looking for. So this is a hybrid game engine with a kind of a designer's approach to learning. This was really in the news recently because Super Mario Maker is soon, I think, going offline, and I think maybe its levels won't be accessible for much longer. I think the whole Wii U network in general, connectivity is getting shut down. And there was a race to defeat the final unbeaten Super Mario Maker level. Because some of these levels, as you can see in this GIF, are, well, Nintendo's designers would never make them this way. Let's take a look. This is on Twitter. They beat the level, finally. So that maybe didn't look like much, but something to note is that this orange ball that the player is messing with has to be thrown and used as a platform and thrown again to hit things and used as a platform, caught, right, with pixel-perfect precision. As a result, the game was extremely difficult on this stage, and so they got it done, okay? Mario Maker is very interesting. It came kind of on the tail of a lot of, frankly, less successful, critically, a bit uninspired games in the new Super Mario Bros. Series. Has anyone seen these games before? Right? These games sold absolute gangbusters. Really, really great sales, but so many games came out looking more or less like this, and it was running a bit dry. Okay, not super creative, okay, definitely not Nintendo's best effort, a real cash cow, and probably sensing that they were running out of time with 2D Mario, they decided to break the genre by saying, you know what, go make it yourself, and they released Super Mario Maker. I want to show you the trailer really quickly so you can get a good feel for what this game is like. right? So you can see that there's a ton of things in this game. And in particular, I want to point something out. This product kind of blurs the line between game and engine. In many cases, when you're making a game, you need to make it, make your changes, design your levels, and then you have to do a compile. You have to wait for a few seconds. You have to go in through the start menu again and then get to where you want to go to test the thing you just made. In this game, you can play the game while you make the game. And in that very first portion of the trailer, you see that, oops, hey, I died there. I didn't like that jump. I didn't like how it feels. Let's turn that into a normal slope. And that's what they did right then and there. They were able to respawn quickly at the right spot. So super fast iteration is the name of the game. And I have to tell you, has anyone ever dealt with like long iteration times? Like you're making a bigger Unity project or you're compiling some Unreal C++, and it's just taking like, I've got this idea in my head, but I'm just sitting here, just kind of like drinking some coffee or something, waiting for it to compile. The faster you can iterate in a game engine, the more fun it is, right? And you've probably had the feeling when you're on a roll in a game engine, you're super excited, seeing your ideas just get in one after another, boom, 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 and it's working, it's getting better. Like, that's a good feeling. Could we bottle that up and turn that into a product? Well, Mario Maker kind of said yes. And it's a super successful title. This will not be the end of the Mario Maker series. I will tell you that. After Mario Maker came out, Nintendo has a big problem. How do we release new 2D side-scrolling Mario games if we got this big editor and all of our craziest ideas are already being made by fans? Well, what do? What did they do? Yes. When the game first was shown off, like Mario consuming flowers, I was like, this is Super Mario Mary Jane, And so we need to make a game that is so crazy, that puts wonder back into people's hearts when it comes to Mario, and something that's so crazy no one could ever build it in Super Mario Maker, and this is the trailer for that game.
Onward and upward.
Right? And that was the basic idea. We need to give our next 2D Mario platformer, which for a while has been, frankly, kind of underfunded, not a whole lot of attention paid to it, a little bit uninspired. They put, I believe, the Super Mario Odyssey team teamed up with the new Super Mario Bros. 2D team to give this 2D platformer a massive AAA budget. And that is something that's fairly rare these days. 2D platformers getting all those resources, and you can really feel it, can't you? The game did really well. I think it sold a ton. The 2D Marios have always sold super well, and critically, absolutely fantastic. So the next question, I suppose, is will the next Super Mario Maker have some of these in it? Maybe, maybe not. Maybe we'll get a 3D Mario Maker. But beyond just how cool this game engine game hybrid is, that timeline of we're going to coast a little bit, oops, we release a tool, okay, now we have to really put a ton of effort in for our next one to keep it alive, I think it's very interesting, okay? A lot of our problems are technical, but a lot are also social. political, bureaucratic, okay? So it helps to keep those things in mind when you're thinking about technologies and what people choose to do with them, okay? Very interesting stuff. And my last thing that I'll show you really quickly here is, yeah, I'm pretty sure this is Turing complete, or at least almost.
Recently, I was wondering if it's possible to build logic gates in Super Mario Maker, and as it turns out, it is. Logic gates are some of the most basic building parts of computers, and it's possible to perform some basic computing tasks with them, like counting, storing information, or doing calculation. I actually found a way to build AND, OR, XOR, and NOT gates, which actually allow for some super basic computing in Mario Maker with some restraints. So at first we'll talk through the gates, and afterwards we'll take a quick look on some basic things that are possible with these gates, including rebuilding the circuit and building a half adder in Mario Maker. So you ready? Let's do this! So the first gate we're going to take a look at is the AND gate. We use questionnaire blocks as inputs and output for all gates in this video. This circuit always gets activated once a P-switch got triggered. So for an AND gate, this means that this block and this block need to be set so that this block gets triggered. Our main source of electricity are Buzzy Beetle shells. This gate is actually pretty simple. Once the P-switch got triggered, this shell drops onto this spring. If both blocks on the bottom were activated, these shells trigger these blocks, which push the bullet bills upwards and allow the shell to hit this block. But if none or only one block was triggered, the shell can't hit the output. So let's take a look at the OR gate. An OR gate...
Okay, so I'll let you watch the rest of that if you're really curious. It seems amazing to me, right? You build like a game, like a Minecraft, you add just the smallest minimal set of features, maybe even without intending to. Oops, you've accidentally made the game Turing complete, and now suddenly you wake up to Twitter posts about someone having built a working basic computer or calculator in your game, and that has to be a pretty special feeling. Looking at how this works, I'm not entirely sure it would have been intentional on the designer's part, but I also wouldn't be surprised if it was. This game does not have any documentation. It's an engine that wants you to work to discover its features, which is kind of interesting in the same sense that you would discover and unlock things in a game. It hides some of its features and it kind of reveals them to you fairly slowly, unlocking new features as you build new things and play through the game and play other stages. And no joke, I haven't played the game a ton myself, but from the footage I've watched, it seems like there are some very important things that they just flat out hide from you, okay, until you run into them or discover them by just talking with others, which is very cool. I don't think there are tool tips. There's a mini game hidden on the title screen. This is like the game designers got hold of the game engine, okay, and what an interesting hybrid to study, okay. So hopefully next time you play Mario Maker, you know, at least the context, the history of it will be kind of interesting to you, okay. All right. We got a little bit more time left. Then we're going to turn it over to Nathan. How is homework 9 coming? Okay, really hard homework. This might be the toughest yet, right? How is it going? Now, I've heard there are rumors on the street that a few of you have finished the goals you had in mind already, and now you're wondering what to do, okay? This was not meant to be a hard assignment. You finished your main exam. This is the victory lap for you, okay? And I hope that, you know, you'll implement things. You'll have some fun. If you have some extra time, that's awesome. You can add new features. But those examples we gave on the assignment spec, some of them aren't big, okay? Some of those features are not huge. And you knock them out, you're going to get those points, okay? Now, on Tuesday or so, you should get feedback from one of the staff members, and maybe we ask you to document things a bit better. Maybe we ask you for a small additional feature here or there, something for you to proceed on in the second week. This isn't going to be a huge thing, okay? If you enjoy your engine, if you feel proud of it, right? If you are looking to maybe use it a bit over the summer, the hope is that, you know, next time you want to do some experiments, you got a cool engine right there you can add on to. The same path that Nikhil and Ravi walked, okay? The same path, hopefully I'll walk. Maybe I'll add some features this summer. We'll have to see, okay? But don't feel pressured to do more, okay? This is not meant to be a harshly graded assignment, but do more if you're curious, okay? And if you're curious whether you've done enough, you can always DM us or ask me during office hours maybe, whatever you want to do, okay? Exam review is coming on Monday. If you are curious about how certain questions were graded, what the correct answer is, then we're going to have some nice information for you then. It should be kind of fun. Yeah, there were a couple questions that wrecked a lot of students, okay? Small ones, okay, not too big. We had no perfects on the exam, okay? And I'll show you kind of why that was. We were very, very close on a few occasions, but no perfects. But overall, he did a fantastic job. I think the average, what was the median? It was like 89%. Very, very good stuff. Well done. The exams are up here in this basket, okay? You are welcome to come up and grab your exam when you want to. I do not need it back. We already have your score plugged in, so you can take it. You can see what went wrong and kind of correct your mental model if something was slightly off, okay? All right. A reminder, first semester, debut semester, and Canvas is being a little bit messy, okay? Oh, you're so eager. Okay, you're so eager. Very good. And it's right on top. Good stuff. So keep in mind, okay, very good chance your grades are going to rise at least a little bit, okay? The grades in Canvas, from what I can see, they're not including the extra credit, right? And there's a good chunk of that. And so don't worry too much, okay? Focus on your other courses, focus on your engine, and you put in a very good effort this semester. If that's so, you got an engine that's going and doing well, you're going to make it, okay? You're going to be all right. Course evals are out. Just another reminder, we really rely on your feedback on the course, your ideas for the course, so please fill those out if you can. The more people who do it, the more extra credit you get at the end of the semester. So please remind your friends, your peers, and we will use that information over the summer to make the course a much nicer experience, a better experience, more productive one, and we really appreciate it. Thank you. Okay, the last thing I want to show you, and then I'll turn it over to Nathan. So I didn't get a lot of sleep last night. I got about 2 hours. And usually that's for a really good reason, right? Like I was upgrading the auto grader, I was finishing an assignment, I was grading your exams, right, to get them back super fast. Or, unfortunately, last night, it was a bad reason. I was watching a 2-hour documentary with Andy Gavin, right, one of the industry luminaries as we entered kind of the 3D era. Famous for what? Anyone know? Oh, you've been impacted by his work, for sure. Co-founder of Naughty Dog, along with Jason Rubin, who is a U of M alum. He was the main programmer on Crash Bandicoot, which was the first kind of really successful, impactful character action platformer in 3D. Okay, there were some other attempts that didn't go super well. Crash Bandicoot came out around the same time as Mario 64. 2 games, right? 2 kind of mascots for the rival, the console war of that period. And they were both very, very different games. They took different approaches, and Crash Bandicoot was miles ahead of other PlayStation games that came out around the same time, okay? And in this interview, you can get a feel for why. This interview clip right here is much shorter. I'll give you a little bit of it. I'll show you another quick piece, and then you'll know there's also a 2-hour version that has a lot of other great stuff in there too. Let's take a quick look, and then we'll get on to Nathan's talk. Quick clip just to whet your appetite. You can watch this later. It's not super long. There are a lot of interesting problems you have to solve when you're on the bleeding edge, okay? Back in those days, you would get a prototype PlayStation, a big weird box. It wasn't even fully complete, okay? It had bugs, it was missing features, and you had to make some assumptions about what the final console was going to be like. There wasn't a ton of documentation, and the documentation you got was maybe it was mainly in Japanese, and maybe like there was a poorly translated English version, and you had to kind of go in there and figure out, do testing to find out what the hardware was really good at. And so you had to fight your way through all that stuff. You had to solve a lot of very difficult problems, many of which were technical. But as you heard, sometimes the solution is based on relationships, right? Andy had some friends. They were making a great game, so they were able to get some attention from Sony to get some of the API changes and some of the documentation he needed, okay? And so I really encourage you, go watch this. And if you're really interested, go watch the 2-hour version that I double speeded through last night. It is incredible. It was a different time in many ways, but especially for those of you working in the XR course, like in a couple ways, it starts to feel a little bit familiar, right? There's not always an obvious solution. Sometimes things break and don't work the way you expect. And something to remember, right? You get rid of some of these, you sandpaper some of these edges off. You step away from the bleeding edge, you're stepping right into massive amounts of competition, okay? If it's easy for everyone, okay? All right, so anyway, very, very good stuff, very inspiring stuff. It's amazing how much Andy can remember for a game that was made like, 1999, I think. So absolutely amazing and very, very rare knowledge. Okay. All right, everyone, we have a phenomenal lecture for you today. Super, super happy to have Nathan here. He's done so much for the local community. He's taken time out of his day to talk to all of you. When I designed this game engine course, I was very much thinking of Nathan, very much thinking of Stardock. Hopefully we can get more and more knowledge on game engines, custom game engines, low-level C++ into this community. And you're the start of that, okay? So everyone, let's welcome Nathan Hainish of Stardock. Thank you so much for being here.
All right. Thank you, Austin, for the opportunity to come here. Thank you, everyone, for your attention. There was a QR code up for the notes. These may be things you want to digest over time, take with you to your future jobs, to your future studios. There's a fair amount of meat here. Don't feel bad if it doesn't all absorb right away. So who am I? I'm Nathan Hainish. I'm the lead developer at Stardock Entertainment. We are by far the largest studio in Michigan, and I believe we are the oldest independent PC game studio anywhere. Okay, so why should you care what I say? Thank you, Austin, for the intro. So I've contributed to over 15 titles on a whole lot of different platforms, different engines, different genres. I've been in there for a lot of the bleeding edge industry firsts and have lost a lot of blood on those. So in the early aughts, I built out an ultra massively multiplayer online role-playing game. We were the first demo and product to ship on D3D12. I think we were like the 5th on Vulkan on Steam. I'm pretty confident I was the very first user of the GOG Galaxy online networking. We were in the first batch on Discord Nitro, literally going back and forth. I'm so impressed with our engineers. We were on Discord with the engineers at Discord, be like, hey, we need an API change, they'll do this thing. They'd be like, 15 minutes, we'll roll it out to you. And they did. Like, it was just phenomenal. Did some work on Stadia. That's all I'm going to say about that. And about a year ago, we were, I believe, the first game to ship in-game Gen AI with Galactic Civilizations for Supernova, where you could generate alien civilizations and conversations and whatnot. That was an awful lot of fun. I've got 2 master's degrees. I'm real active in IGDA Detroit and Ann Arbor. I strongly encourage you, if you are interested in doing this professionally or even as a side fun thing, come to the meetings, meet the people, get a little more context, and the presentations are always great. I also ran a chapter in Alabama, Huntsville, Alabama, for about 3 years, about 20 meetings there. And most importantly, I regularly make hiring decisions for engineers wanting jobs in these roles. Okay, so I'm going to talk about coding standards. I know it's so exciting. There's, flashy graphics and it's all text. It's going to be a little dry. I apologize for that, but it's important enough that I think every line on here could save you days of time. thousands and thousands of dollars, save your companies millions of dollars. For real. So failing to do these things will lead to end user crashes. You don't want that. Players get mad, they go on the internet, they say mean things, which leads to public embarrassment, days of pulling your hair out, debugging, leading into a big release, or realizing you put something out that had a really nasty bug, loss of productivity, long iteration time. This is such a killer. I'm going to go into that a little bit more, but we at Stardock really focus intently on getting iteration time down literally into the seconds or sub-second range when we can. Missed opportunities is actually huge. I've been in projects where, man, if we'd gotten to market 6 months earlier, a year earlier, I would be a much wealthier individual, let's just say. And, general pain and suffering. And I will also say, working in the industry for the last 25 years, I run into these things literally every single day with professional teams who should know better. So one of the reasons I chose this as my subject is I want to get in front of you guys. You're like, if you're coming into a studio day one, you really want to have this knowledge, apply these principles, please. As a lead, I'm begging you, please. Okay, a few notes before we get started. This is going to be about C++. Not everybody uses C++, but they should. It's still relevant for C# and whatnot. Don't use Java for games. I did that, and we had to rewrite it all in C++ because C++ was 1,000 times faster. The standards matter more when you're at low-level libraries than they do up at the top at like Lua or Python gameplay code. They still matter up here. They matter a lot more down at the bottom layers. And please feel free to take these and share them with your friends. Okay, these are the areas I'm going to be talking about. I don't think it's necessary to read the table of contents. So take a look and we'll dive in. Okay, type safety and initialization. So I will say, this one in particular, we had a very, very long weekend going into releasing Galciv 3 because somebody didn't initialize a variable upon declaration, and that would cause a crash. It's like, if there were particles shown in the previous frame, then one of the variables wasn't initialized and would crash. And it took us like 4 senior engineers, 5 days solid to find this. But it was one of these bugs that had to be fixed, or we couldn't ship the game, which had already been announced, all the marketing lined up, and could have been saved by just, if somebody had just been scrupulous when they're writing code in the first place. Similarly, every struct, every class should have a constructor that initializes all of its members. In C++, there's a lot of different styles of initializers. Just make sure you initialize. Or if you're not initializing, at least do a memset 0, so you have a defined state. Specific data structures like structs, classes, and strong types instead of built-in types. So this kind of goes with the object-oriented principle of you want to work in the domain space of your problem rather than in the domain space of C. In particular, the strong types are a big deal for us because it prevents accidentally converting from one type to another. So concrete example on Galciv 3 again, we had player index and player ID. And most of the time, those were the same number. They're both uints, you can pass them back and forth, no problem. Right up until you add a new, one of the civilizations splits and you add a new faction. And now suddenly those numbers aren't the same and everything blows up. So basically we went through and every single place where there's a semantic meaning for that type, you put it in a strong type, you can no longer cross assign. Saved so many bugs. Be specific and clear with integer types. So I just detest the C style, long, unsigned. Who knows what that means? Well, in fact, it means different things depending on what computer or console you're on. So please, use named sized types. Be explicit. This matters for a lot of different things. It matters for alignment. It matters for understanding what's really going on in your code. And it just makes it a lot easier to read. Similarly, for sentinel values, when you're initializing an invalid, don't use 0 or -1. Please because those end up being what you call in-band signals, where 0 might actually mean something good and mean something bad, and now you've got a problem. Or, more importantly, with -1, and we've gotten burned on this one too, -1 isn't -1. Right? If you're comparing, it's like comparing two floats for equality. Comparing -1 for equality in two different types, they're not the same number. So, yeah, make real invalids. Handles instead of raw pointers. This was pretty hard fought and won knowledge here. So, in the old days, we would allocate a bunch of objects, store pointers to them all over the place. We'd have dangling references. You'd access that reference, everything would blow up. Nowadays, we have, like, let's say you've got your game objects. You have an array of game objects, and it doesn't have to be an array, a container of game objects. You hold on to a handle. The handle might be 17. You can always get back to entry 17. You can get its pointer temporarily, but then between frames, be like, you know what? I don't have all of these objects in the middle. They got deleted. Move them around in memory, for instance. And all of your problems with crashing because of dangling pointers go away, and you have the ability to rearrange things in memory. Similarly, don't keep pointers around for a long time. You're just asking for trouble. Function scope is good for us. Occasionally we have utility functions you can call passing in a pointer, but like that's the limit. Don't keep pointers around. Plan for objects to move around in memory, especially with standard containers or other containers like vector and queue. If somebody adds one more entry, that whole vector may get moved around in memory silently. And if you happen to be holding on to a pointer, that pointer is no longer good. And this gets a little bit into, I've got some slides on multi-threading later where that ends up mattering a lot more. Naming, we prefer to put P on the front of pointer variables. It just helps somebody who's going through to spot, oh, this is a pointer, this is not a pointer. I need to pay special attention to it. Pet peeve, I see a lot of this on new people entering the industry and just putting auto everywhere. Like if I wanted a weakly typed language, I would use Lua. I'm using C++ because the compiler will find errors for me. And it finds a lot of them. Like no programmer is infallible. I'm doing this for a long time and I write bad code all the time. The compiler really helps you out and helps you to reason about what's actually happening in your code. If I hit a hunk of code and it's just auto all over the place, I don't know what's going on. And it can be remarkably difficult to figure out what's really going on, even stepping through in the debugger. Acceptable uses, if you've got like a template or you're dealing with iterators, then it's generally okay. Like if you've got a type that's this long, yeah, use auto for it. Otherwise, use the actual type. Class inheritance. So you learn C++ in college, you're like, object orientation is great. We can make, an object that, or a triangle, that's a polygon, that's a polynomial, that these class hierarchies that are really tall and have diamonds in them. And in practice, our class hierarchies are maybe one parent class ever. In fact, we've really moved away from a lot of object-oriented methodologies, which I'll get into a little bit more. But keep your class inheritance simple. If you can turn warnings as errors on, please do, especially if you're starting a project. And in particular, treat type conversion warnings like those are errors. Those are errors that you just haven't realized yet. C-style casting, it's just old style. Use C++ style casting. It's a little safer. It's a little more explicit. If it's not a static cast, you're probably doing it wrong. Make sure you look it up. Like if you're doing a reinterpret cast, be real sure you know what that's actually doing in memory.
Box2D kind of requires it, from what I've seen.
And a lot of C libraries do.
Yeah.
Just, I'm saying, be careful. Because when you're casting, things can happen that aren't what you think is happening. Avoid changing variable types. So if you're putting a float into an int and into a float, that's actually really expensive, especially if you're doing it in a tight loop. You're moving between different kinds of registers. It's not as trivial as you think that it is. And if you're using constcast, again, I've had like 2 valid uses of constcast in my entire career. If you're doing constcast, you're probably doing it wrong. It sounds obvious, right? If you've got a long function, break it into smaller functions. And yet I run into tons of code where, like, there's this 500-line function that has accumulated a little bit from 10 different programmers over the course of a decade, and now nobody knows what it does, and everybody's afraid to change it. This kind of goes with refactor as you go. If you find yourself wading into one of these functions and it's got a bug in it, almost always the solution for me is go ahead and refactor it, break the chunks out into separate chunks, move your variables closer where your declaration closer where you're actually using them, get rid of your early returns, and very often in the process of refactoring, you'll get rid of the bug. Not always, but it really helps. And there's just the cognitive limits of a human make life a little bit easier on yourself. So declare variables as close to where you use them as possible. That just limits the span of code you have to keep in your head when you're trying to debug. And I've got an example there. Early returns. I hate early returns, and here's a classic example of why. I've got a thread resource, I've got a file resource, I've got a network resource, and somebody put in an early return, and now the file's open forever. I run into this code all the time. I'll say, when I was at Electronic Arts, this was a strictly verboten, you never ever do it. Big studies, places like Microsoft have gone and been like, all right, where are bugs coming from? This is number one. Number one, don't do early returns. There are a few cases, but if you can at all avoid it, don't do early returns. State machines instead of multiple Booleans. So I run into this constantly, especially with like code going into a lobby, going into multiplayer, or dealing with network code where somebody's like, well, I need a bool for I'm in game or not. And I need a bool for am I first player or not. And I need a bool for whether this step has been initialized. And pretty soon you've got 8 different bools that are being managed in 10 different call sites that are no longer coordinated with each other. And you do things. When I came onto Star Control Origins, for instance, you would go to somewhere in the multiplayer flow, and depending on which button you hit to go back, you would go to one of 3 different screens. The solution for those always ends up being make a state machine with exclusive states, do transitions from state A to state B, and if you have side effects that have to happen, do them there. And that becomes infinitely more manageable. You can print out your state to the console. You can actually see what's happening. And you can detect when you've gone from one state to another state, and you shouldn't have been going between those states. This one kills me. And I see this in like professional engine code from ourselves and other vendors. Please don't call functions in if statements. The reason being, if I'm looking at this code, even if I'm looking at this code in the debugger, I don't know what those returned. And getting that information is remarkably difficult. And typically, if you're the person writing the code, there's some concept you have associated with the return of each of those functions. Put it in a variable. Like, we have scads of memory. Like, we're not on PlayStation 1 anymore. Put it in a variable, make debugging easy. Designed for debuggability. Similarly, refrain from calling multiple functions in a single line of code, which I also see all the time. In this case, if that middle function returns null, you just have a crash. And it'll happen, when the reviewer is looking at your code, or when some important Twitch or YouTuber is playing your game. Never ever dereference the return value of a function without checking for null. It seems obvious, like just don't do it. I've got another point on that one later, so I'll leave that for that then. I really hate default initializers. So you think, oh, this is convenient. I'll just have 3 or 4 default initializers. That way I can just have one version of the function. I can use it in all these different ways. And inevitably what happens is somebody comes in and let's say they put an int parameter at the front. Well, the compiler will now happily convert all those call sites that we're passing in a bool. It'll just make them ints. And now they're not doing what you think that they're doing. Prefer variables or constants for passing parameters to functions. Magic numbers are bad. Bad. Don't use them. If you're using a number twice in your code, ideally once, but definitely if you're using it twice in your code, it better be in a constant somewhere. I can't tell you how much code I've gone through, especially like really complicated low-level algorithms that are just filled with magic numbers, and like nobody wants to touch it because they don't know what those numbers mean. Tell me what the number means. Give it a name, and it's constant. Return values, I believe, should always be put into a variable. Again, you want to be able to see what it's doing in the debugger. I like to put a int result at the top of the function, put a default value in it, return at the end. I can see what's happening. Never ever invoke a function on the return line. Again, I have no idea what that returned. No way to look at it. Resource acquisition is initialization. It's really handy for dealing with, I've opened up a file pointer, I've opened up a network resource pointer, I've opened up a thread pointer. I need to be really, really sure that however I exit this function, that resource gets cleaned up. And I've just put up a really simple guard class that just, in the constructor, it grabs a hold of the pointer, and the destructor, it does a delete. That way, no matter how you exit that scope, your important resource has been cleaned up. Always check if pointers are non-null before you use them. So at a minimum, put an if. If you can, put an assert. Sometimes you need to add a log line there. I almost fired a guy because he put in the assert and no if check. And we had like 10 different call sites that would crash, that like somebody took the time to recognize this is a bad situation. I should catch it and then not actually deal with it. Like, don't be that guy. Similarly, if you're working with exceptions, so you're working in Java, C#, or you've got exceptions turned on in C++, catch all the exceptions. Because if you do not catch an exception, that's a crash. Okay, I'm going to take a breath here. Performance and multi-threading. So sort of the preface here is premature optimization is the root of all kinds of evil. When you're writing code in the first place, you probably think, oh, I'm gonna make my C code more concise. I'm gonna do this thing that I think is going to make it faster. 90+% of the things that you think are going to make it faster don't. And they make your code harder to read. The only way to know if what you're doing is effective is you have to profile it. Like, that's it. There is no other way. You're not going to guess. The compiler is smarter than you are. They're doing so much code rearrangement, you wouldn't believe it. You have to profile. And then spend the effort. Is very much a Pareto principle thing. 10% of the effort will give you 90% of the results. I don't think I mentioned explicitly here, but you guys are all EECs, right? So you've actually had hardware architecture classes. Good. That will set you apart. Actually understanding what the CPU is doing is a thing that sets students with some double E aside from students who took some programming classes. And it ends up being pretty, like, maybe if you're writing .NET code, it doesn't matter. If you're writing game code, it really matters. You have to actually care what the hardware is doing. Memory pools and custom allocators. So here's an anecdote. When I was working on an MMO, we were using Gabriel engine, it was NetImmerse at the time. Started running profiles and like, oh, they're allocating 12,000 objects every frame and then deallocating them and allocating and deallocating them every single frame. That's really, really expensive. So we made a custom new and a custom delete, and we made an array, like a simple container, and start the frame, just grab them out of the array, right? That's literally just memory lookup time. When you delete, just mark them in the array. enormous performance implications. And fragmentation isn't as big of a deal as it used to be because we've got essentially infinite virtual memory. But at the time, fragmentation was really a big deal. Gameplay code shouldn't be doing dynamic allocations, especially not in a tight loop, because it's expensive, basically. False sharing. So when you access a piece of memory, the cache is really smart and it says, oh, I'm going to go ahead and grab the next 100 lines, 1,000 lines, whatever bunch of memory for you. Okay, if you're running multi-threaded code and I've got one thread working on this line, one thread working on this line, one thread working on this line, well, each of those core caches are pulling the same hunk of memory, and now I have contention over that same hunk of memory. Whereas if instead you're like, thread 1 works on this block, thread 2 works on this block, thread 3 works on this block, you're no longer fighting over your cache. And that has pretty significant performance implications. Use SIMD instructions where you can. So if you're doing a lot of like matrix multiplication, frankly, the compiler is going to do it for you anyways, but bother to line up your structs on 64 byte, whatever the appropriate alignment is, and call the fast version. And you just have to look up what those are for your different vector math. But it makes a big difference for vector math. Align as, so a lot of those functions require alignment, but also if you're pushing data across the bus, pushing 32-byte aligned data as opposed to 31-byte aligned data is an order of magnitude faster. It makes a huge, huge difference. You want to minimize cache misses by using cache line sized structs. Try to avoid virtual functions. There are places where you need them, but typically templates are going to give you better polymorphic behavior from a performance standpoint. Never, ever compare strings in code. Maybe there's a couple of cases, but by and large, use string hashes. It's a bazillion times faster. All right, so this adhere to established multi-threaded practices. I've got basically a book list at the end. This is a class on its own. I'm not going to go through all of it, but if you can take a class on multi-thread and multi-core, do that.
How many of you have taken EECS 482? It's a good choice. Okay.
Yeah. Everybody else take it. The single skill that I have the most trouble finding when I'm looking for candidates is multi-thread and multi-core programming. I'm running on a 64-core CPU. 9 out of 10 programmers I interview don't know how to make that run any faster than a 1-core CPU. Like, there's so much performance on the table for learning how to do these things. Easiest thing, like atomics and test and set. So atomics are ways that you can, like it's an easy way to deal with addition, multiplication, sets, that sort of thing in a multi-threaded environment. Learn to love lambdas, async, and futures. So futures are the thing that was added to C++ relatively recently. Lambdas are anonymous functions that you can then pass into async calls. But basically, these are a great way for structuring your code for asynchronous behavior. So we use this a lot for things like we have like a parallel sort, or you can apply parallel tasks. So break this chunk of work into an arbitrary number of tasks and do the async version and let me know when it's done. And that's 90% of where we get our performance boosts. It's just recognizing I've got a big chunk of work, breaking to pieces, doing it asynchronously across threads, and then moving forward when it's done. Some idioms that will help you there are you want to really clearly separate the code that writes to shared memory, your writers, and the code that reads from shared memory. Separate the code, separate them in time. So you can have like the writers working now and the readers working now, and you can have as many readers as you want all at once outside of the little bit of time that you actually need to write to that. Makes a big difference in performance. Message passing and work queues are a pretty good way to deal with multi-threading. I've got some work. I don't need the result right now. I'll shove it into a message, throw it on a queue. A worker can deal with it later, and pass me back a result through another message. Most game engines will have a main thread that is talking to the graphics hardware. With DirectX 12 and Vulkan, that's a little bit less the case. On our games, we actually don't have a main thread anymore, but most of them do. Don't do blocking operations on the main thread after you've kind of gotten to your main menu screen. Like, do not access the network and wait around for 300 milliseconds or sit in a file open on your main thread. Consider multi-core cache behavior when setting up memory layout. So the big one here is array of structs versus structive arrays. The way we used to do things is I'd have this struct that, I'd have my player class, or actor class, let's say, and I'd have 10,000 of them. And it would be health and the rotation and the translation and 18 other different things related to that actor. And if I want to then go through and just look at the health, I'm now stepping through a ton of memory and I'm bringing in that whole actor object every time I just want to look at the health. Whereas if instead I've got an array of health for everybody, an array of rotation for everybody, I can jam through the health and I'm not hitting any more memory than I absolutely have to. On modern architectures, the time to hit a register is something like 1,000 times faster than the time it is to hit main memory. Like, memory bandwidth limitations are huge. Thread local storage is just a really handy way for dealing with quasi-globals or quasi-statics where you need a bunch of different copies depending on the thread you're in. Code and quality maintainability. Enforce a code review process. So the single biggest way I've seen really big projects that cost tons of memory go off the rails is by not having code review. So having code review, one, it makes you more honest because you have to explain it to somebody else, forces you to sort of rubber duck with yourself. So you'll find your own errors faster. The person you're explaining it to, as you verbalize it to them, will also find errors. You'll prevent having broken builds because at least somebody's running it on a second computer. So every single day it's, somebody forgot a header file. Somebody didn't put something in their change list. And that would have broken the build, which would have stalled the team, which if you're on a big team gets extraordinarily expensive really, really fast. I broke the build one time at EA. I had 20 people outside my cube in 5 minutes. Like, hey, I can't do any work until you fix this thing. All right, I'll get on it.
There was I had some students on a very well-known first-person shooter that didn't do super well. And for weeks at a time, they could not build their game.
Yeah.
And the result was as one would expect. It was a disaster.
Yeah. So this is the number one way you prevent disasters on big teams, is you have code reviews. Also, on even a medium-sized team over the course of a project, like projects are running years now. Let's say a AAA project might run 5-6 years. There's going to be a lot of turnover. Sharing that knowledge between members of the team prevents catastrophic failure. Regularly refactor your code and reduce technical debt. The big thing that kills lots and lots and lots of projects from having a successful second project is all right, they finished the game, we made a bunch of money, or are we going to make a second one? Oh God, nobody wants to touch that code anymore. You have to, it's kind of like real debt. Cleaning your room, you have to pay down technical debt over time. If you're going into code to fix some bugs, you've already unwrapped in your head, which is the expensive part, go ahead and do some refactoring while you're there. Like, pay it off bit by bit. Document the rationale between non-obvious design decisions and complex algorithms. And this can be as little as link to the Wikipedia article in a comment. I can't tell you how often I've walked into an algorithm and been like, this is really complicated. I don't know what it's doing. I don't know why it's doing it. I don't know why somebody chose to do it. Just a little hint would have made a big difference. Clear module and component architecture to encapsulate functionality. I mean, that one kind of speaks for itself. Like, complexity is the enemy. Any way you can break things apart, please break them apart. Use good naming. Like, don't make it unobvious what a function's doing. Like, letters are free. use them. If you have magic numbers, at least comment them. Better yet, put them in named constants. Or better yet, data drive them. I know you talked about data driving. We're quasi-religious about data driving. So we use a lot of code generation using, what's the word I'm looking for? Like Corba-esque or Google, the buffers. That one. That sort of approach for an awful lot of our code and our data types. It's really helpful to have a schema of some sort in some language that allows you to do things like validation, make sure all the fields are filled out, make sure that they're within reasonable ranges. And as you're putting in the data, if it's in XML or if it's in JSON, if you've got a schema, the tools will really help you out. Especially in the age of GPT, they really, really help you out to have well-structured data. Implement validation checks. This, again, prevents your game from crashing. Hot loading. This is a big deal. So we hot load all of our data. We hot load all of our UIs. So if you're in-game and you're like, I really want to rebake this map. I want to reload the terrain. I want to change out this UI element. You change the data, you press a button, 3 seconds later, you're looking at the new data. This saves literally hundreds of thousands of dollars, if not more, over the course of a big project. Just that one line. There's one line. If you forget everything else, do hot loading. This is one we're moving into now is automated testing. QA is great and all. Player tests are great and all. But if you can build automated tests that, one thing we're moving towards, and this is kind of inspired by Austin's work on the autograder, is we're essentially at the point now where I can build an automated test that will record all of my keystrokes and mouse movement and whatnot, go through each of the screens in a game on a build, save out a screenshot. Now a producer can come in, load up the CI/CD build that ran the automated test, get a single context sheet, and be like, oh, that one UI is screwed up. The cost of fixing something that got broken goes up dramatically every day that you go past where it got broken. So the sooner you can realize, oh wait, we just introduced an extra 2 gig of memory usage, or we just broke a UI, the better, because very often the way you solve those problems ends up being a binary search. Or if it's a binary search over 20 change lists, that's a whole lot faster than a binary search over 10,000 change lists. Const reference is just faster. Use it. And if you're not modifying state, use const. That's kind of basic stuff. Keep application-specific code separate from low-level libraries. So I run into this a lot where somebody's like, I'm just going to call directly into zlib, let's say, and kind of infect the code base with that. A much better approach is to define a header that says, here's my compression, here's the 2 functions I need to access, hide that implementation. That way, if you want to go from zlib to glib to blib to pkzip, your application code doesn't have to care. Organize code in multiple independent files, sure. Lambda functions are great. You should use them, but use them in the right way. I spend a lot of time scanning through code. Very simple things like putting, / and a bunch of dashes really speeds that process up. At the end of the day, my core skill as a developer is search a word. Anything that makes that faster saves cognitive load. I'm less fatigued at the end of the day. I can get a lot more done. Any strings touching a protocol or external interface, they can be UTF-8, they can be UTF-16. The point is, pick one. Don't do like every code base I've ever been in that has 4 different string types, and you're constantly translating between them. And this one handles some Japanese okay, and this one handles some Arabic okay, but they don't mix well. Like, pick a standard, stick with that standard everywhere. Increasingly, it's like you're looking at UTF-8 is going to be the winner there. For us, because OpenAI and the other LLMs insist on UTF-8. Has downside, though, which is you can no longer be dependent upon your strings being arrays, simple arrays. If you're not using bucket builds, you will encounter bucket builds, and this is basically a way of taking all of the C++ in a given project and shoving it into one big C++ file so that as the compiler is going through, it doesn't have to reload headers, which is super for making your builds faster, but it has the side effect that people will just forget to put headers in. And then you go and do something like move to a console that doesn't have a bucket build, and now you've got 1,000 build errors. Or I'm making changes to one C++ file and really want to see if it compiles or not. I really need to be able to right-click on that one file and say compile just that one file. The other half of that is don't put in unnecessary headers, like you're just slowing down your build time, which acts as a tax in your project. So ReSharper is great for this. Simple things like sort them alphabetically. Like I'll every time I go into a file refactory, I'll grab all the headers, put them in Excel, hit sort, put them back, and be like, oh, these 4 are duplicated. Okay, well that's 2 minutes of my day every day that I just saved. Maybe not 2 minutes, but like it adds up. If you're using, so this one, was it like the Mars rover? Like there was a big important NASA robotics on another planet project that failed because somebody was working in centimeters and somebody else was working in inches and they didn't know it.
It accelerated at high speed into the planet.
Yes. So if you're doing something that has physical units, real world units, put them in the name and use the right units. So if you're talking about duration, use duration, don't use speed. They're not the same, they're inverse of each other. And prefer, if you're talking about like showing data to a designer, use units they understand. So maybe internally you use radians. If you're putting up a designer editable wizard, use degrees. Your designers don't know what radians are. Refactor as you go. A linter is great. You guys know what a linter is. Pick 1, pick 5, use them. I've taken a habit of in Visual Studio, I'll do just Control K, D, lines up everything consistently, gives me spaces instead of tabs, and even that will expose errors. Like, oh, I had the return in the wrong line in the wrong bracket. But linters will save you a lot of pain. Yeah, if you can do warnings errors, do that. It's tough to do on a legacy project. Similarly, I didn't see it here, but if you can use multiple compilers, do that. Like Xcode and GCC and what's the
Visual C++.
Visual C++. What's the other big C one? Clang. They will all show you different problems with your code. And everything that they show you is a real problem that should be fixed. I'm going to kind of breeze through this one because it's every studio does it different. But for capitalization and casing, be consistent. Like your studio has a standard, use that standard and use it everywhere. Oh, okay, here we go. Static asserts. If you've got something like this struct can never get too big because then it exceeds our network buffer sizes. Like make it explicit because somebody will violate it at some point and then wonder why they're losing part of their message 1 in 10,000 times. I spent 2 days on that a couple of weeks ago. If instead of ifdef, this one, seems nitpicky, but it's just better to use if instead of ifdef for obscure reasons that you run into when you start doing cross-platform stuff. Label your else, pound else, and pound else if and end ifs, because otherwise what you run into is code that somebody wrote a few years ago that you come into and like, oh, there's 4 end ifs in a row. I don't know which one's which. Like, just put comments on them. Similarly, pragma once, it's a little thing, but you can use pragma once in your headers instead of the pound if def, pound define, pound end if paradigm. It's just a little cleaner. Pragma region, end region, super helpful. That way you can fold portions of your code. Again, saving cognitive load as a programmer, like it really adds up. It will make you more efficient. Just, clean. It's a cleaner room sort of thing. Don't put using namespaces in a header. What you end up with there is somebody will include that header, and then they'll just not be putting the proper namespaces on things, and then the header will go away, and then a bunch of code won't compile. Static variable initialization. So this, you cannot depend on the order because it changes. So this is basically all your globals, which there are valid uses for globals that are narrow, but your code's going to have them. Really importantly in this one, if you have a static initialized variable, so global, in a lib, like if something gets compiled to a lib, if that lib gets included twice, you may now have 2 copies of that variable, which turns out to be really hard to debug. Don't use inline and class declarations. In my opinion, don't put any implementation code in class declarations. This slows down your compiler time significantly. It makes it harder to read through the header code. And like, we're in C++, we're not in Java. They're different languages. Just don't do it. There are cases where you need virtual functions. They're narrow. Again, if you can use templates, do that instead. Typedef templated types readability. So nobody wants to come across this 27-letter, 3-template deep type and use it over and over again. Like if it's, my collection of clams, like typedef clams, so I know in domain space what I'm looking at. Avoid mutable. This messes up your threading. And unless you're doing like memory mapped IO or something where you actually need it. Static analysis will save you so much time and effort, it's unreal. Every time we've run static analysis, it has found really hard bugs that no human would have found, but were definitely real. So, yes.
I was just going to ask which static analysis
All
tool
of them.
do you use? All of them. Okay.
As many as you can find, use every one of them. They will all show you big problems with your code. I have been shocked and ashamed at some of the things they found, especially if you're dealing with a legacy code base. Those will save you days and days worth of effort. Use a linter, use multiple compilers. For declarations, so if you just need the compiler to know, like, there is a type clam, right? Just have a forward header that just says struct clam or class clam and doesn't have all of the includes that a clam needs in order to compile, or like compile time adds up. Forward declarations is a way to help with that. If you can integrate unit tests and integration tests into your development workflow, that's going to save you time and effort. If you can do continuous integration, so that basically means there are variations of this, but in practice for us, it means every time somebody checks something in, we run an automated build. Maybe we run an automated build, automated test. You find your compilation errors a whole lot faster, especially if you're dealing with multi-platform. And it's not that hard to set up a continuous build. Also, real importantly here, when you have that, I broke the UI sometime last week bug, if you have continuous builds going and those are being saved off to a server someplace, you can be like, hey, producer, go test the last 20 builds, as opposed to, hey, lead dev, go binary search all of those builds. Big time saver. Implement stress tests. So this kind of goes back to the optimization thing. You don't know where your performance problems are until you stress test, and you're not going to guess. So build a stress test and see where things break down. Run some benchmarks, once a day, once a week. When your memory spikes by 4 gigabytes, and it will happen, you want to know that right away. When your frame rate drops from 120 to 20, you want to know right away. We actually mostly grab third-party libraries at the beginning of a project and never ever change them. You should at least have a policy. And this kind of goes with third-party tools too. Like, decide when you're going to move to the next version. Everybody agrees on that. You don't have one person be like, Yeah, I just uploaded upgraded to Visual Studio 2025 and wrote some code that doesn't compile for anybody else now. Sorry. A lot of the value of a studio, a lot of the value of you as an individual in a studio is accumulated knowledge. No fooling, half the value I bring to Stardock is that on day one, I opened up a text document and I started typing stuff in. There's a shocking amount of information vital to our business operations that only exists in that text document. If I could go back, I would have held every single person's foot to the fire and be like, you have to put stuff in Confluence or Wiki every single day. Like, I kind of fought that battle, but I didn't fight it hard enough, and I'm lamenting I should have gone back and done that. We've gotten a lot more rigorous now. Encourage your team members to give talks and lunch and learns and write articles. You find a lot of really bright, creative, interesting people on games teams who are doing really interesting stuff in their spare time or learning really interesting things on the job. Get them to share that. It's really enriches the value of being in the studio, and you will learn really important things this way. Also, document things that can go wrong. There's a lot of this. What this is documenting things that can go wrong. If you're doing code generation, we do code generation. If you're doing like binary file generation with tools, make sure there's a timestamp in there so you know which version of the tool was used. Also, get in the habit of making canonical builds with versions on them. Otherwise, you'll have here's a binary file that, this was built off a Luz machine last Tuesday. We can never, ever generate that again. Be formal about your tools. All right. This is in the notes, but go read all these books. For real. It'll take you weeks, but you'll be better for it. I'll be happy to take questions. I do want you to take one picture.
Absolutely. Nathan, thank you so much. I'll take some photos as you answer questions.
And I'm only over by 4 minutes. So go ahead.
So you mentioned code generation
Yep.
In your slides. Does Stardock use code generation and what are the trade-offs there?
Yes, we use a lot of code generation in any way that we can. I will say that 2 different angles on here. One is, yes, I use GPT every day, and you should too. Don't lie about it. Don't pass it off as being your own work. But if it saves me several hours a day, especially I need this throwaway Python script that's going to take all the files in this directory and convert them from Targa to DDS. I'm never going to write that script as fast as GPT is. It's not going to the end user. It doesn't need to be quality controlled. It'll save you a ton of time. When you get into code that's actually going to ship, you actually need to be sure that that's right. But we do a lot of code generation around our gameplay data types and around types that will be persisted and pulled off of disk, around types that will be sent over the network, and around types that last one. But basically, interface definition language. That's what the word I was looking for earlier, which is a concept we took from Corba. We end up using XML XSD files as sort of our definition for the interface. Tool generation also. And from that, we can generate here's a header that describes it in C++. Here's a file that describes it in Python. Here's a file that describes it in Qt. So now, for very little effort, we've got a UI for manipulating that data and packaging it up and throwing it in a save game and pulling it back out again, sending it over the network between a client and server. There's a lot of rote and mechanical code. I don't want to write that 1,000 times. It's much faster to write a tool that does it for me. And if there's a bug, I fix it once instead of fixing it 200 times.
Do you have any advice for it's like this felt like years and years of knowledge as you enter the industry to continue learning outside of necessarily what you're expected to do as a worker?
My advice to everyone who walks in the door, and I would pass it on to you guys, is expect to spend at least an hour every single day studying something that is adjacent to your work. So for instance, I do game dev, but I'm really interested in digital audio. I'll learn about that, or I'll learn about AI techniques. So at a certain point, you run out of brain juice for the thing you're doing that you're getting paid for. But there's an awful lot of things that are close that it's free motivation for me anyways, and that accumulates over time. I had one guy, one of my best devs, who his first hour, he would get there early. His first hour or so is he's getting the latest version out of the repo and doing builds. There's a decent amount of dead time on any given day where you're just building. He would run C++ conference proceedings every single day for an hour or so a day. And that knowledge really adds up over time. Get involved in professional groups. Get involved in IGDA. Ann Arbor has an embarrassment of riches in terms of good technical groups that meet regularly. Meet and talk to those people. There's a lot of knowledge diffusion that happens. I love going to the meetings and talking to students because you guys will tell me about new things that are happening that I didn't know about. But it has to be an everyday, forever.
Do you have advice for avoiding header errors or circular dependencies and bigger projects?
Not really. I will say, so circular dependencies both in headers, and we use CMake for setting up library dependencies, and we're really scrupulous about that. The one thing I will advise is, so we'll have problems where we've got a 4 or 5 layer architecture, and something at the bottom, the top layers know about all the things below them. Occasionally, something down here is going to need to make a call up to here. And the only way to really do that is either through a message passing interface or one of the higher levels registers a callback with the lower level. And that's effectively how we broke those loops. I will say I have looked at other big name engines that you've heard of that do a really awful job with this.
So what do you do when you take on the dependency of an external piece of code, and you find out that you have to make a change to that code? What do you do in that case?
That happens literally all the time. One is any third-party dependency we bring on, we do our own build, which can be a gigantic pain in the neck. It is not. At some point, we took our Windows engine. We're like, we really need this to run on Linux, and so we had to go and build every one of those dependencies on Linux. So one is be scrupulous when you're choosing third-party dependencies. Picking open source software is like dating. You don't really know at first whether it's going to work out or not. But you have to be scrupulous about which ones you pick. Favor those that have good build systems. Look for stuff that supports CMake. Expect to build it yourself and have it in your own versioning system. And yes, occasionally you'll need to make edits. It doesn't happen in practice all that often. We had to make a change to zlib for something with international characters. It doesn't happen a lot.
I just asked because I have a physics core that gets progressively more difficult with real physics, and NVIDIA doesn't take yards on it. So
Yes, and I've dealt with that with even when I was using Gamebryo. We had made now Gamebryo is really good with multi-threading, In 2003, Gamebryo couldn't cope with multi-threading at all, and we were building an MMO that had to have multi-threading. So I made a lot of changes to it. And I'd submit them back to the company and be like, oh, that's neat. So yeah, I lost a lot of time going from version to version. And you have to be, there are a lot of important trade-offs you make on a big project as to when you update versions, do you really need the new functionality? And the closer you get to ship, the harder those decisions end up being.
So you mentioned the students moving away from object-oriented style.
Mhm.
So what are you guys doing to organize?
Oh, that's a great question. We're really moving towards an ECS type approach, entity component system type approach, which we were doing before it was cool. Back when it was like, I'm trying to explain this architecture and nobody knows what I'm talking about except this one guy who worked on Lumberyard. And now, like, everybody knows what it is, and it's not as cool anymore. But that's largely driven by, we will use all the cores. Like our simulation, if you throw 120 core systematic, we will use all those cores. And ECS turns out to be really well aligned with that.
Like you mentioned hot reloading as being like one of the most crucial performance factors that like help speed up the engine. I was trying to do that for my own engine for this class, but I couldn't find any resources. What are the major feats you have to achieve with the current engine so that you can turn it into something that can support hot reloading?
Hot loading, you said? And a lot of it is just going in with that assumption that you will be hot loading, and those there are certain things that will continue to work as long as you don't violate them working. So, start with a small version that can load the data files, and then don't ever make any changes that prevents you from being able to reload those data files. And I know that doesn't help that much, but it's hard to retrofit, I guess is what I'm trying to say. Yeah, go ahead.
One more question is for maintainability with having an audit base of the code base, do you use Doxygen? So while people are writing code, do you encourage them to Doxygen format
Sure.
your code throughout as you're writing it? So Doxygen could generate the docs.
It helps. It's certainly better to use it than to not use it. I've not had a lot of luck enforcing that on anybody. If you can pull it off, that's great. I will say, even in really well-documented libraries, I still end up having to go through the code in a debugger most of the time to figure out what's really going on.
How do you normally go about trying to create automated testing?
That's a great question. So I'm not the one who implemented it. What I will say is, what a lot of it boiled down to was recording keystrokes, mouse strokes, just into a plain text, JSON format. Being able to export screenshots, store those off, being able to, we've got pretty robust persistence libraries. So being able to take the game state, persist it out to a save game, and then you can do binary comparisons. Or if you're real good and you've got versioning, you can even compare different versions of the same, what amounts to the same actual data. And those are the biggest parts, is you've got to be able to save out game state, load in game state.
What do you think qualify someone entering the gaming industry? What do we need to prepare for way everyone trying to have a job in those gaming studio, and especially for the current job market, which the gaming industry doesn't look so good. So what will be your advice for those graduating students like us?
Mm-hmm. That's a good question. I will say the things that I look for, I won't hire somebody without a 4-year degree because of the rigor that you get in that. I won't hire somebody who has not done a team project of significant complexity. Like, you don't have to make Half-Life 3, I don't need that, but it needs to be reasonably complex, and it needs to be with other people in multiple disciplines. So the senior design projects are fantastic for that. The current job market is a temporary thing. We are experiencing a correction because everybody in the industry went into COVID and said, wow, we're selling 20% more copies than we were yesterday. Good times are here forever. So step function, and then they weren't. And everybody's like, all right, 20% of everybody needs to go. And that correction, best estimates I've heard are that's probably another 12 to 18 months until we're through that. There are still jobs, though. Like, we're still hiring. A lot of smaller studios are still hiring. Mostly where you've seen the drawdown has been big companies that are answerable to shareholders that won't get yelled at for bringing down their costs if their rivals all did the same thing. And it's, like I said, it's a temporary condition. So I hate that it's happening to you guys now, but this will not still be the case a couple years from now. And the reality is there are never enough good engineers. Yeah, go ahead.
How do you go about presenting your work, like, to other people? Like, I know I did talk to a lot of people about, like, yes, we've done all these projects, but, like, how do we show people what we did?
And a lot of that's stuff you do for the senior time, like put up a portfolio page, go to IGDA events and show it off there, put it up on itch.io. This weekend, this Saturday at the Ann Arbor District Library is actually a game dev day where you can see a lot of independent projects. I showed last year, but I'm busy this year. But those are the primary ways.
In a week, you'll be submitting your final custom feature in the form of your online portfolio. So you'll have one in a week if you don't already.
And yes, people doing hiring look at those in great detail.
So you kind of mentioned this with like writing a TXT file when you start working at a new job.
Mm-hmm.
Like, how do you like? What are like tips you recommend for like when you start a new job in software development? How to like make sure you're always learning, keeping up with like new standards of the company, making sure you're like learning properly from senior devs as well. Like, what's the best way to approach that process so you get the most out of the position?
Ask a lot of questions every day. Don't be embarrassed about like looking dumb. You won't. Like, it is literally impossible for somebody to know all the things. If I bring on a new dev and they're not asking me questions, that's a big red flag. So ask a lot of questions every single day. Take notes. Pick something to study every day, and just repeat that forever. Good.
This might be a silly question, but do you have any favorite class that you took as an undergrad or grad that you thought did well for your career?
Oh, absolutely. I had the privilege in 1998 to have a lab full of SGI and Sun machines, and an excellent professor, Dr. Tim Newman, if you're listening, who taught a couple semesters on actually 3 semesters on computer graphics. And that was absolutely transformative for me. So I was able to be doing OpenGL before the overwhelming portion of the population had any clue what it was.
And then just, I guess, follow-up question is just, do you find yourself doing things? You said you're curious in digital. What was it?
Digital audio.
Yeah. Do you find yourself doing, even though you code 8 hours a day, do you still find yourself still doing outside of work? Gotcha.
But I do different things.
Yeah.
I haven't heard from you.
So I've been trying to shift my engine towards a more data-oriented approach for a bit now.
Yep, good.
I was wondering if, in switching to the ECS kind of approach at start off, if there have been any growing pains. Like, certain things have been a little difficult for me. Sorting those struts of arrays, little tiny things like that. So I was just wondering, switching over from the object-oriented approach, have you hit any snags or growing pains?
A lot less than you would think. Most of our pain has been around some of the code is still the old way, and some of the code is the new way, and wrapping those up sufficiently so they don't cross-infect too much. And the other part of it was just getting everybody on board with the approach. We all like to think that we're nimble thinkers and flexible, and then you throw Ruby at us and like, I don't want to touch this new thing. Like, you have to maintain your plasticity, I suppose is what I would say, as long as you can. Like, this industry continues to change radically all the time, not like in the 90s, 80s, but it's still, big changes are happening on a yearly basis. I like the shirt, by the way.
Thanks. What's a tool or technology, a new tool or technology that you've been interested in recently that you think will have an impact in game dev or programming?
I just got the VES book on virtual production with Unreal 5, and I'm really excited about it. This is the notion you can strap your phone to a gimbal and now you're looking around a sea. Like, that's just so cool. So I think there's definitely some interesting game adjacent work. And that's another thing I would say is I've spent most of my time in the game industry, but some of my time in defense simulation work. And we've got a lot of friends in the community that there's a lot of work one step removed from games, where these tools are finally getting so good and so fast and so reasonably priced that I think there's still a ton of growth to be had one step outside of games. Like with virtual production, the economics there are profoundly in favor of virtual production over actually going on site. Like, there can't help but be an explosion of work there.
So actually, just a follow-up question based on that answer. If you are trying to get into game development, are virtual production skills something that's still marketable and applied to those roles? Or
Yeah, there's a lot of crossover.
okay, how would you, I guess, want to market that if you're trying to get into a developer position?
A lot of it just comes down to showing that you can do something of reasonable complexity. Like, don't tell me, show me.
So you were talking earlier about the value of documentation for a programming team, but what are the highest priority items for a team to document?
Things that were hard to figure out that would be... So if it took me, and this happens all the time, it took me 3 days to figure this stupid thing out, and it was 3 lines of code. Document that. And I'll take screenshots. If I've done something hard, I'll go through it a second time and I'll screenshot the whole process. And that might take me 15 minutes, but it will save somebody else 3 days multiplied by 20 or 30 or 40. Like, the returns for that sort of thing are just ridiculously high.
You've had an amazing career, it's still going. What is your favorite or funniest bug you've ever encountered?
Oh, God. There have been a lot of funny, embarrassing animation bugs. So what it all boils down to in the end is some vertex transform became degenerate. So on Wish, the MMO I worked on, we were really bleeding edge, and we were doing programmable shaders from day one. And we had a big beta we were putting out, and AMD put out a new GPU 2 days before. And when those players logged in, they walked around with Christmas trees on them. And we're like, we don't have the hardware to figure out why the transform broke on these machines. So you mentioned the relationship thing earlier. Yeah. That's actually really important. So especially being on the bleeding edge, there's a ton of work that we couldn't have done, couldn't have completed, shipped, what have you, without really tight interpersonal relationships with people at the IHVs, at the consoles, at the publishers. I can't overstate the value of those things. And having somebody on your team who, can talk to other people, like it's not me, but we've got a guy, and like that really sets us apart from a lot of other AA studios.
Our community is so fortunate to have Nate here, to have Stardock in our community just 20 minutes away. So much knowledge, so much inspiration. We can't thank you enough, Nate.
Thank you.
All right, everyone, thank you for joining us. I'm going to put the QR code back up. Go ahead and scan it. I'm going to make sure that this gets put on YouTube. You can watch it again later. You can watch it in 5 years when you're in that big game studio trying to help them fix their coding guidelines. And everyone on Twitch watching at home, we will see you later. Thank you so much. Bye-bye.